shows the numbers that we talked about. It actually gets even more specific. What you have at the bottom of this normal distribution curve. Now, normal distribution really just means it's symmetrical, okay? And I'm pretty positive all of your questions will say like something along the lines of assume it's normally distributed. And so, we're using these numbers. At the bottom, we have standard deviations. So this is a half of a standard deviation above. This is one standard deviation above. So put standard deviation. If you remember back to Friday with that Marvin Harrison one, I kind of came up with what the numbers would be. So let me show you that really quickly. So here's for Terrell Owens. His one standard deviation was 2. So I just labeled that new number. Here was his 14-point average, and one standard deviation above was 16 points. Here we're just labeling it based on standard deviations. And then obviously here's one standard deviation below. So from what we learned on Friday, that should be approximately 68% of the area under the curve. Now, if you add up all of these numbers, 15 plus 15 plus 19.1 plus 19.1, it's actually giving us an even more specific 68.2%. One standard deviation above and below. Then if I jump to 2 standard deviations above and below, that percentage is going to increase by 4.4%, 9.2%, 9.2%, and 4.4% gets us up to 95.4%. I gave you the numbers 68 and 95. Okay, so those, again, we're ballpark. 3 standard deviations away, we haven't talked about this yet because it's not going to come up as often, but if I add on to that 1.7% and 0.5%, that gets us up to 99.8%. So it would be highly, highly unusual, a 0.2% chance. Think about that. That's less than a 1% chance that someone would fall more than 3 standard deviations from the average. Okay? The average goes in the middle. Okay? 0 standard deviations away from the average is the average. And then we go out from there. Okay, so just a little more detail on that graph. You don't have to memorize the 0.2% and the 0.4%. Just stick with 68 and 95. But I wanted to show you a normal distribution curve and really point out that sometimes you can have raw numbers on the bottom and sometimes you can have standard deviation numbers on the bottom. That's important because either one could be thrown at you. So if we jump to exercise 1, again, there's that precursor information. For a population that is normally distributed, find the percentage of the population that lies within 1 standard deviation. We're going to use that chart exactly, assuming that they gave it to you. 68.2%. 2 standard deviations we already did was 95.4%. How about more than 3 standard deviations? Not within 3 standard deviations, but more than 3. What percentage is more than 3 away? Raise your hand if you think you know. Aiden? 0.2%. There's that 0.1% and that 0.1%. So that's 0.2%. Between 1 and 2 standard deviations above, so specifically above, between 1 and 2. That's this section right here. So we just have to add 9.2 and 4.4, and we get 13.6%. Any questions on that? Okay. At Arlington High School, 424 juniors recently took the SAT exam. on the math portion, the mean was 540 with a standard deviation of 80. So what I always say to do here is kind of get your graph started. What number goes in the middle, Cameron? What am I going to label this? 540. And assuming I'm just going to label one standard deviation, not a half, what number would go here? You may need to use your calculator if you can't do mental math here. 620, good, Nate. He went one standard deviation above, so he added 80 onto that. Connor, what would go here? One standard deviation below. 460, very good. And let's just take it a second standard deviation above, so 620 plus 80 more would put you at 700, and 460 minus 80 more would put you at 380. Okay? There's one standard deviation, too. Now let's take a look at the questions. What percent fell between 500 and 660? So, now 500, that is a half of a standard deviation, isn't it? Isn't 500 halfway between 540 and 460? So we're talking a half of a standard deviation below, 1/2 standard deviation below, to 660, which is how many standard deviations above? 1.5. 1.5, correct. To 1.5 above. So we jump to our chart. We're talking a half standard deviation below, which is here, to 1.5 above, which is there. So do this for me. Add up all those percentages. 19.1, 19.1, 15, and 9.2. Grace? 62.4%. Good. How many scores fell between 500? How many scores? So do you see the difference between these two questions? What percent of the scores versus how many, like looking for the raw number. So you know it's 62.4% of the people who took the test. Well, how many people took the test? 424. So we need 62.4% of 424 juniors to figure out the actual number. So on a calculator, just to review how to calculate percentages, that would be 0.0624. Of means multiply by 424. 0.0624 times 424. I screwed up. What did I screw up? Yeah, it should be 0.624. Sorry. I knew that because I got 26 kids as my answer. And so just based on checking that doesn't make any sense. We want 60%. That's over half. So I knew something was wrong. So it should be 264. Now these are people, right? Remember, these percentages are just estimates still. So I'm just going to round that to the nearest person. So that would be approximately 265 of our juniors. Okay, so here we have a different scenario that we have to think about. Evan scored a 740 on her exam. So how many standard deviations is she above? If she scored a 740, there's 1, 2.5. Yes? She's 2.5 standard deviations above. So if I go to my chart, 2.5 is right here. This is where she scored. What percentage scored better than her? Add those up. 0.6%. The better question that you guys might not realize that you are given a lot of times when you take standardized tests is what percentage did worse than her? 0.6% did better. 99.4 did worse than her. You know how when you get your exam scores and you read your percentile, right? You're in the 99th percentile. That's really good, right? Because that means you're scoring better than 99% of everybody else. So you're in the top 1%. Did you know that that's what percentile meant? I think probably at some point. This is where it comes from, okay? So I'm just going to add this to this because it's going to come up. She's in the 99.4 percentile. Meaning she did better than 99.4% of the people. And then the question is approximately how many. So again, they're looking for a raw number. How many students did better than her? So we need 0.6% of 424. That's 0.006 times 424. I don't think it's going to be a lot of kids. I got 3. I got 2.544. So that's approximately 3 students did better than her. Okie doke. Any questions so far? So the heights of 16-year-old teenage boys are normally distributed. Again, that's 16. You got to look for information and numbers that don't do anything for you. That's just telling you the age of the kids that were surveyed. Are normally distributed with a mean of 66. So let's draw that. 66 right in the middle. And a standard deviation of 3. So 1 standard deviation above is 69. 2 standard deviations above is 72. And that's this Jabari is 72 inches tall. So he's right at the 2nd standard deviation mark. Which of the following is closest to his percentile? Okay, so if I go back to my chart, he's here. What's his percentile then? Raise your hand when and if you when you figure it out. His scores would come back and say he's in the blank percentile. I see Nathan and Andrew have it so far. And I see a lot of you are taking the longer way, so I'm going to ask one of these quick boys how they got it so fast. Cameron, what do you think? 77th percentile? How'd you get it? You got the right methodology, but I think that you might have hit a wrong key or something. So double check that you added 1.7 plus 0.5 plus 0.1. Did you do that? And then you did 100%. What did that number give you? And you did 100% minus 2.3? Why'd you change 2.3% to 23%? I think maybe you might be confusing this when we are taking the percentage of something and we have to change the percentage to a decimal. Does that make sense? Because you are right. These add up to 2.3%, which means if 2.3% are above, then that means, what'd you get, Bo? 97.7% are below. How many of you added this plus this plus this plus this plus this plus this and we're going that way? Raise your hand. Just a little longer, right? So almost like the idea of complementary events that we just did with probability. It's easier just to come up with what's the percentage above and then subtract it from 100. So it would be 97. Oh, you picked. Is that why you? Oh, not 67. 97.7%. Is that why you picked that, Bo? Because the answers were wrong. It's the nearest whole number. Good. Exercise 4 here gives us the amount of soda in a standard can, normally distributed with a mean of 12. Let's get that. Picture drawn. Standard deviation of 0.6 ounces. So 12.6. 2 standard deviations would be 13.2. If I go 0.6 below, I'm at 11.4. 0.6 below that, 10.8. Okay. If 250 soda cans were pulled, this is kind of like the 424 juniors number. This is giving you a raw number. How many would be expected? So again, how many? They're not asking us for the percentage here, although we're going to need to find it. We're at the end of all of it, asked for the number out of the 250 that would be expected to have less than 11.1. Now, where's 11.1? How many standard deviations away? Everyone see 11.1 would be right around here? Yes? That's 1.5 below. So if I go to 1.5 below on my chart, that puts me here. What percentage is below that number? So I have to add those all up. 4.4 plus 1.7 plus 0.5 plus 0.1. 6.7%. So 6.7% of the 250 is going to give me my answer of how many actual cans. So 0.067 times 250, 16.75, nearest whole number, 17 cans. That's expected. Is that guaranteed? No. So if it was ever an open response, you would say about 17. There's that being generic and never definitive with your explanations and stats. Right? They give us good predictors. They don't give us guarantees that anything is going to happen. Let's jump to just this last thing on the back because I want to make sure we get to the vocab. Nathan. Yeah, that ended up just being like when I took another look at it, it was the proportion stuff. So like we did it, actually one of the questions that was asked on the homework, we did an example of that, like what proportion actually fell between. So you just take your 9 out of 15, I think it was on the homework. Okay, thank you. What about distributions that aren't normal, right? Because not everything is perfectly centered. So if you take a couple of charts that I have here at the bottom, this one, and I'll say it tails off to the left, okay? And when it tails off to the left in that, that highest part of our curve is not right in the middle, we call that skewed left. Wherever that tail is, if it tails to the left, it skews left. And this one tails more to the right than it does in the other direction, so we would say that this is skewed right. Okay, so I just want to get those vocab words out. I don't need to do any more with that. So I just want to make sure we touch that. Okay, so let's go back here to this red king crab situation. We have a sample, and you guys don't need to do this, I'll do it. Remember how we enter data, so edit. For the sake of time, we'll watch 9.8, 10.1. Tell me if I type anything in wrong, because I'm going to try to do this fast. Okay, there's all my crabs. If I go to my last thing, I have 16 of them. Am I supposed to have 16 of them? Oh, it doesn't say. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We've got determine the mean and the sample standard deviation. So we go to stat. I run a calculation, one variable statistics. I don't have a frequency, so I'm getting rid of that. Calculate. So my mean is, did it say it around 10th, 12.6? What is my sample standard deviation? Which one's sample, which one's population? S. The S is the sample, so 1.5. Why does this sample indicate that the population would be well modeled using a normal distribution? Oh God. Okay, I'll tell you why. If we were to sort this is a concept we haven't really talked about yet, so I'll use this as an opportunity to teach it. If you sort this from smallest to biggest, your median number in the middle is going to be pretty close to your average. So when your median, write this down, when your median is approximately equal to your average, that's a good indication that it's a normal distribution. Okay? If you're skewed left or skewed right, your average is going to be fairly off from the median. Right? Take a look at those last two graphs. My median, my middle's right about there, isn't it? Would you say that's approximately the middle of my curve? Yet the average is going to be way up there because of the way this is